Good morning, people. Good morning, Mayuri. Good morning, Sushil. Ishan. Sanmit, good morning. Saraswati, good morning. Avi, good morning. Ayush, good morning. Kalyani, good morning. Sarvade. Swapnil, good morning. Rameshwar, good morning. Karthik, good morning. Rishikesh, good morning. Okay. Ajay, good morning as well. Okay. Aishwarya, good morning. Uh, well, today is the 26th of November, and we know that one of the most unfortunate of the attacks, I would say, as far as terrorist attacks is concerned, happened in 2008. You all must have been very small then. 10 years ago, you all must have been 7 and 8 years old then, possibly. Prachi, good morning. Anjali, good morning as well. I remember it very distinctly, basically because then, that's in 2008, I was working in a college in Mumbai, the Sidnam College of Commerce and Economics, was where I was working then. And I used to travel to Mumbai regularly. And I still remember, Bhavika, good morning, that 25th evening I came back. And it was a late coming, I would rather say. And that's why I did not it's my habit to go into the news, late night news as such, but I did not see that. And because I was traveling from Pune to Mumbai, I used to start early. I used to take the Sinhagad Express as such. And Danish, good morning. And it so happened that the next day I took a train from Chinchwad and we were in a group. All of us were hardly aware of anything. We went till Lonavala, and then the news came to us that there is a terrorist attack in Mumbai, and that the firing is still going on. Of course, trains did not proceed beyond that. But then we came back from Lonavala to our respective homes, and then the next couple of days were basically how the government tackled the whole thing. Initially, the Mumbai police, of course, we had the martyrs there, and then the national forces came in, and of course we all know rest of it is history. You will be seeing this throughout the day on some of the news channels as such. But that just a few people could hold a city for ransom was something very threatening then. But fortunately, because of our brave policemen and soldiers, we are safe. I would rather say we should be thanking them. Today is also the National Constitutional Day, Constitution Day. So that is another thing that we should be keeping in mind. The third thing that I wanted to discuss about is that maybe by next week we will be shifting on to our Google suite as such, and that's why it is very important that all of you all have your IDs ready by then. If you don't have your IDs, please let me know on the group. We will have to work out something as far as those groups are concerned, because as far as I am told, as far as students are concerned, unless and until you don't have an ID, you would not be able to enter a class. And yes, these would be the last days as far as no attendance tracking is there, basically because as far as G Suits is concerned, there is an internal mechanism wherein it's not only that you log in and then you move out, but it can track as to how many times the student has logged in and logged out and so on and so forth. So uh, I just tried to push it a bit, delay it rather, I would say, that because of the fact that I know that once G Suits is there, attendance is going to be monitored and your other performances would accordingly be monitored also. Um, in a couple of days, I'll also announce a few assignments that we would be taking up. Vikshit, good morning. A few assignments that we would be taking up so that we could mark you. You all know that you will be marked for 40 internal marks, and you would be having your 60 marks external exam as such. That is how it makes up your 100 marks as per subject, that is. So these are a few things that I wanted to refer to. We are into the process of learning what the interior of the earth is made up of. And I do remember that we were into what we did speak about these aspects, right? The various properties of the interior of the earth, how much of the crust makes up the earth, how much of the mantle makes up the earth, how much of the core makes up the earth, what is the state, what is the depth, density, what is the chemical composition as such, and so on and so forth. We also spoke about the fact these were those details as such, and we also spoke about the fact that the various minerals that make up these Earth's crust and the entire Earth, and we see that it's so very varying, and it's because of this varying that we could say that yes, there are differences, and we are going to have different layers as we move towards the center of the Earth, and that the surface is much less dense as compared to the core, and so on and so forth. Then we spoke about some more properties as far as the interior and layering of the Earth is concerned. We also spoke about the types of rocks as such, and then we went into the heat and gravity and how we have these convectional currents within the mantle, and what are the temperatures at different levels as far as the interior of the earth is concerned as such. Yes, we are going to move ahead today. However, before moving ahead, I did put up a question that are you tracking the Nivar tropical cyclone that has already struck, I would rather say, as far as the southeast coast of India is concerned, the states of Tamil Nadu, particularly the northern parts of Sri Lanka. And this information in front of you all has been gathered from the weather and radar map that we have. I have asked you all to, and I'll just take you through it, how things change and how actually a geography student should not only be with reference to what is happening at that particular moment of time, but we need to see what happened yesterday and, of course, what presumably would be happening tomorrow and onwards. So, yesterday, this was the scenario, and you'll see that the newspapers today are flooded with two things: the death of the football legend Diego Maradona, and of course, the second thing is the striking of the Nivar cyclone. Okay, these are the two front pages, and of course, various news channels and of course newspapers are carrying photographs also. So it already has made a landfall. Now, what does a landfall? It's a typical term used for tropical cyclones, wherein the tropical cyclone comes onto the uh, on the land surface, because there is where the actual say destruction starts. So uh, say the time, the date of the landfall is a very important concept as far as tropical cyclones are concerned. This is the picture yesterday. Then, as far as today's picture is concerned, okay, not much change you would see, okay, because this is yesterday night, possibly yesterday night, and this is today morning. This was around 7:15 in the morning today, as such. But if I go for tomorrow, there is a bit of change. You'll see that the proper circular shape of the um, tropical cyclone possibly would change, which would open up, and then you would be having heavy rains in these parts, and of course you'll see the trail of the clouds. In fact, till yesterday we also had a significant amount. Day before yesterday also we had some amount of cloud cover, but now because the tropical cyclone has gathered it together, you'll see that at least these parts of Maharashtra are clear of the clouds as such. We may not have rain as such tomorrow. As far as day after tomorrow is concerned, you'll see that you see this red spot here. It's believed that you would have heavy rains here, and as far as other parts are concerned, we would have lesser amount of rains. And day after tomorrow, that's Saturday, we could have a cloudy day once again. Also, here, major parts of Maharashtra may be covered with clouds. And another important thing I would like you all to observe is this part here. Okay, while one dissipates, possibly there is one more which is coming up, and you'll see that if I look into the Sunday scenario of what should be happening, uh, the clouds in Maharashtra may have dissipated by then to a significant level, still having some of them. But what is important is there is one more cyclone which may develop, rather which has developed, and which may move towards this. So this is going to be a difficult time for the people in Pondicherry, in southern parts of Andhra Pradesh, and of course along the coastal parts of Tamil Nadu and the northern parts of Sri Lanka, also as such. So it's we will have to wait and see. Actually, you see that many a times it so happens that new scenarios pick up, and as a consequence, this may not actually happen. But I've seen that 90% of these um, forecasts have always been true. The intensity may change here and there, but yes, we will have to be on our guard. Okay, this is the major advantage that we would have as far as forecasts are concerned. That we know that this thing is going to happen, and that's why. And in that case, we would actually be protecting our property, and more so life in the form of human beings and other animals also. So a student of geography should be using the weather and radar app with that uh, context, that what say you have to have a timeline of what would be happening with any extreme meteorological phenomena or any other phenomena as such. So that is one thing that I wanted to just bring to your notice. And then let's go to the last of the slides that we had been speaking about. And what's interesting is we have different types of waves that come up with regards an earthquake. And you'll see that there are these terms called as epicenter and focus of an earthquake. I'll be referring to that as well. You'll see that we have different types of waves. We have P waves, we have S waves, and you'll see that they are passing not in a straight manner, but they are passing in a curved manner, basically because say they reflect from the surface, and the surface we have seen last time is less dense. So the moment it enters denser parts, of course, it tries to enter the denser part, but then it is, I would say, shooed away from the denser part, and it still keeps on continuing further, but it gradually shifts towards the less dense part, and that is why these general curves that you would see as far as these waves are concerned. Okay, the bottom diagram here is how you would see these different waves as such. P waves are a very gentle shake. S waves is more prominent, and surface waves, in fact, is the most prominent, and that is why you'll see that as far as the surface waves are concerned, they are supposed to be more destructive comparatively. And as far as the timings are concerned, you can see that if P waves are striking at around 10:20, okay, you'll see that S waves would come around say around 40 minutes, so 10:40, so 20 minutes, and then another 30 minutes you would have the surface waves as such. So it's not that all of them come together, but they come one after the other. That's basically because of the characteristics of each of these waves, and we're going to go into the details of the characteristics of these waves as far as movement, propagation, etc. is concerned. And of course, an important aspect is that the movement of these waves, and because of this movement, we have what is called as a shadow zone. Uh, it is at a particular angle from the epicenter, as I said last time also, and I showed it to you here also, that this earthquake is not taking place at the North Pole. It's taking place somewhere in North America, and they have adjusted it to understand the other aspects. So similarly, every earthquake is understood in this particular way, and they say that okay, if the earthquake is happening at 12 o'clock, the zero there represents 12 o'clock, of course, on our clocks. The epicenter is 12 o'clock. Then uh, say from that point, an area of around 103 degrees to 140 degrees on either sides, 103 to 143 degrees on either side, will not have these waves, and the reason is interesting about it. But before we go into the technical aspects of knowing what a shadow zone is, etc., we will go into the other details of an earthquake, and let us see what we have to learn more before we come back to the shadow zone as such. Now, an earthquake happens way down somewhere in the interior. It could happen within the crust. It could happen much down into the mantle as such. The deep, and accordingly, you'll see that they are classified in the sense some within 50 kilometers they would be called as shallow earthquakes. Okay, within 50 kilometers obviously would mean that they are within the crust. As it starts entering the mantle, you would say that these are deep-seated earthquakes, and the deepest of the earthquakes are around 800 kilometers from the surface. So you could say that earthquakes come up from or arise from the asthenosphere, not much deep than that. So what we call as the lithosphere, 100 kilometers, okay, and the lower part of it. The maximum limit to which we have this earthquakes arising from is 800. The deepest of the earthquakes recorded, let us say, is 800 kilometers. Now, anywhere you may call it a surface earthquake or shallow earthquake or a deep-seated earthquake. The point at which this point here, the point at which the earthquake is initiated, this is called as the focus of an earthquake. The focus, okay, from where it has started. Now it so happens that it's you can see it's very similar to just throwing a stone into a calm surface of water. Now, because you throw a stone at a particular point, the point at which the stone lands in water is the impact where energy is deposited, and you'll see that this energy makes the water move in all directions. You'll have those concentric circles which emerge out of those waves as such. Similarly, as far as earthquakes are concerned, you would have those concentric circles evolve in the outer direction from the point where the energy is being released. This energy makes the ground to shake, and this shake happens in various directions, and accordingly we have various types of waves. Now, if you see that if I take the first concentric and the second and the third and the fourth and the fifth and the sixth and the seventh, of course, some have already, but you'll see that comparatively, this one is the nearest to the surface. For our purpose right now, understanding, this wave front is the nearest one. And you'll see that if I just say enlarge it, okay, you'll see that the first, if I enlarge the circle of that, it will touch the surface. Now, the point at which this is going to be touching the surface, okay, scientifically, mathematically, is the point exactly above the focus, because that's the nearest the surface is from, and that is why you'll find that it is touching the surface there. The point at which the wavefront touches the surface is exactly 90 degrees above the focus, and this is where you are going to experience the earthquake first, and that is why this is called as an epicenter. Students I see are many a times confused with what is the difference between epicenter and focus. In fact, even I used to be confused when I was a student. But once you understand where exactly what starts, okay, the focus is from where it originates, wherever in the interior of the earth, and epicenter is where the shakes are reported the first. Mathematically, this is the point exactly 90 degrees above the focus, exactly above the focus on the surface. So this should explain the terms. Sorry. Okay, this is the epicenter and this is the focus. And a cuboid thing, this is interior. Okay, focus is in the interior, and epicenter is the point exactly above it on the surface. This is the epicenter. And then, of course, you'll have concentric circles. It will spread from that particular point, and things will keep on shaking and so on and so forth. As far as this shaking, etc., is concerned, it is actually measured by an instrument which is called as a seismograph. Okay, you'll see that I was reading of a textbook of I think eighth or ninth standard very recently, and they have an assignment wherein they have to build their own, so to say, a seismograph. You'll see that they try a weight, and then you have a spring, and you'll see that the spring is very sensitive, and to the weight further you have some pointer. Okay, so you'll see that when the earth will start shaking as such, okay, the weight will be attracted because of the shakes, and it will move, and the spring will accordingly make it move, and the pin tied to that will obviously give you how it is moving as such. And you'll see that this instrument is called as a seismograph, and the plot of this would be like this. Okay, the plot of it is going to be like this. You have very advanced mechanisms which are nowadays, this is a very crude one, let me tell you. This is a very advanced thing which is happening, and you'll see that all types of earthquake waves are being recorded on this instrument, and you'll see that it is hosted in a very separate room, etc., because it's on this that the lives of many living organisms, human beings included, will be dependent on. So it's very necessary that you have the best of the facilities to record this so that you can predict it in the future also. So this is the seismograph, and it is here that it is this way that it is actually measured. It's called as a Richter scale. Richter is again the name of the person who gave us this particular scale. It is dependent on the magnitude. Now there are two scales. I'm coming to that. Richter scale is basically on the magnitude, the physical aspect as such. Okay, so and the Richter scale varies from 10, that's 0 to that's around 2 to 10. Okay, in fact you'll see that from 2 to around 3.9, okay, they are called as minor ones, micro, okay, minor, and minor. Okay, since up till 2 it is micro, then 2 to 3 it's minor, 3 to 4 it is minor again, 4 onwards you start says referring to it slightly as such. Now, what does it feel like? The micro ones are hardly experienced by us. It's very sensitive people only who would be able to say, they immediately say, did anything shake around? These are those sensitive people. Otherwise, you'll see that it's only recorded by seismographs. Nobody else will feel it. Okay. However, remember, it's millions of such micro earthquakes happening every year. But because it's very, very subtle, it's very, very general, and only the most sensitive of the people would be able to see that. It so happens that we don't or see in the sense or feel that. However, when you come to a bit higher, okay, a few people feel them. Okay, however, there is no damage to property as such. Good quality buildings don't just shake and fall off as such. While the earlier ones, micro ones, happened millions. Okay, the minor ones happen around 1 million. As you further increase it from 3 to 4, majority of the people start feeling it, and now you will see that objects start shaking. Okay, objects which are not on a very proper and stable balance will start shaking, and they'll make those noises as such. Okay, you'll see that you have something which is not in perfect balance and it's on a surface which could make noise. You'll see that it shakes there and you get that noise. Okay, so that's how it would happen. Many a times you'll see that if you have large window panes in your house, once every couple of days at least, you will see that you'll get the sound of those window panes as such, because you'll see that more than 1 lakh of such things happen, such earthquakes, earthquakes of such magnitude happen per year as such. And of course, they are distributed all over the earth. It's not one particular place as such. 4 and onwards, you'll see that you'll start feeling them. Okay, many people feel it. Okay, indoor objects may shake, and as I said, some which are not in a perfect balance may fall off from shelves, etc., onto the floor as such. And such earthquakes occur to around 10,000 to 15,000 per year as such. Moderate earthquakes start from around 5, and of course, the intensity goes on increasing, the magnitude goes on increasing. They can damage and destroy buildings which are not properly designed architecturally. Mud houses, you'll see that walls will fall off here and there, and to quite an extent, everyone will. Okay? Even the dumbest of the person, I would rather say, would feel it as such. But we don't have them many. It's only 10% of what you see in the earlier category. While you had 10,000 to 15,000 there, you have 1,000 to 1,500 here. And in fact, you'll see that it is decreasing. The frequency of occurrence is decreasing 10 times every. Now, this is a very peculiar thing, and I'm going to come to that as well. Then, as far as 6 onwards are concerned, these are supposed to be strong earthquakes. There is a lot of shaking, and this shaking spreads in to distances away from the epicenter also. Up till 5.9, most of the things happen around the epicenter. Now you'll see that the waves start traveling further, the damaged buildings away from the epicenter, and you have around 100 to 150 happening of them every year. You'll see that you'll have them in earthquake prone areas. Now in India, the Himalayas are very earthquake prone, so I would say a significant number of these 100 to 150 would happen in the Himalayan chains also. Major earthquakes are classified with those having magnitude of 7 and above, that's up to 8. Widespread damage in many areas, and you'll see that once again the occurrence is further decreased 10%, I would rather say, of 100, so 10 to 20. 8 to 8.9 is great, huge amounts of destructions. You have tsunamis, etc., over the seas, and these tsunamis would lash up coasts of different continents also. But the frequency has gone down further 10%. It's only one in a year of such things. As far as 9 to 9.9 are concerned, these are severe ones. Okay? And you'll see that you can literally feel that it's like sitting in a roller coaster ride, wherein you would experience those. Even if you are sitting in a very safe premises, it may not get damaged, but the shaking is always going to be there. You'll have these one per 50 years, I would say, 5 to 50 years as such. 10, an earthquake of magnitude 10 is massive. However, it is believed that it is not recorded. 9 was 200 years ago. This happened in Alaska, not beyond that, never recorded as of now. Now, if you see the two aspects, the magnitude aspect and say the frequency, you see that frequency, it starts with millions, then it comes to 1 million. Then you have 1/10 of that, that's 1 lakh here, 1 lakh per year. Then you have 10% of that. Then you have 10% of that, 10,000. Then you have 10% of 1,000, that's 100. And then 10% of 100, that's 10. And 1 out of 10, that 10. This ratio of increase and decrease is called as a log scale. Now, why I'm referring to this log scale is basically because your magnitude scale also is a log scale. So the difference between an earthquake of magnitude 3 and 4, or let us start from first 2 to 3, is that if the destruction is if we are to calculate it in numbers, okay, hypothetically, if at 2 it is 10, the destruction of 3 or the magnitude of 3 is 10 times that, so it will become 100. As far as 4 is concerned, 10 times that, that's 10 times 100. So with every increase with one magnitude, the intensity, however, increases 10 times. Now, why this is done is basically because if I keep on monitoring different earthquakes, okay, on an arithmetic scale, that would require a very huge scale. So what I do is I compress that. How do I compress that? I unitize the scale but the proportion with which the units increase is on a log scale. So while on an arithmetic scale, you have units on an x-axis, which would be 1, 2, 3, 4, 5, 6. Here, in a log scale, your units, first unit would be 0, second would be 10, third unit would be 100, fourth unit 1000, fifth unit 10,000, and then 1 lakh, and then 10 lakhs, and 1 crores, and so on and so forth. So with every unit, the intensity increases 10 times. That is what is meant by a log scale. I think you must have done this in your earlier classes also, but for those who have missed it out, then it was just a revision aspect as such. So a Richter scale is basically measuring the magnitude, and this magnitude scale is a logarithmic scale, is what you have to remember predominantly. And that is why within a space of 10, you'll see that the intensity increases very fast. In the sense, a hypothetical situation of an earthquake of 10 on the on the Richter scale would be something like, just like you have waves on the surface of the oceans, you'll have similar waves of on the land. The intensity is so huge. Okay, and here you need to realize that 2 is micro, hardly anyone say feels it. To immediately by 10, you'll see that you could just see the land surface which is crumpling, coming up and down like a ocean or a sea wave as such. So that is what a scale of a log scale is concerned. You'll see there are a few more scales which are measured on log scale. I would like you all to just give me examples of similar scales. I can right now remember of 2 of them. Besides the Richter scale, let me tell you that the pH scale, the purity of water scale, is also a log scale. And we know that neutral, it does not start with 0. It starts with 7. The pH scale starts with 7. 7, 8, 9, 10, 11, 12, 13, 14 is increase in the alkaline nature of the liquid, while 7, 6, 5, 4, 3, 2, 1, 0 is basically increase in the acidic. So acidity and alkalinity are opposite to each other. They start with a 0, which is actually marked at 7. And while 8 is alkaline, 6 is acidic, 9 is alkaline, 5 is acidic, and so on and so forth. Remember, we've taken this example because it's a log scale. So 7 to 6 is going to be 10 times more acidic than it was at 7. 6 to 5 is going to be 10 times more acidic than what it was at 6, and 100 times more acidic than 7. Okay, 5 to 4 is going to be 10 times that of 5, 100 times that of 6, and 1,000 times of 7. So acidities of around 5 and onwards, that's 5, 4, it starts getting very acidic. You'll see that acid rains are also measured on this particular scale. So that's another example of logarithmic scale. And by the by, there is one more, your decibel scale to measure sound pollution. Decibel scale is another scale which is measured in a log scale. Okay, so that is as far as the Richter scale, the seismograph, and the plotting of the seismograph is concerned. Let us move ahead. As I said, there is one more scale that is called as the Marcelli scale. Now, this is basically based on the effects. It's not a scientific one. It's more on observation. You can see here. I'll just take you through them one by one. Marcelli scale versus the Richter scale. It's not rich. It's the Rick. You pronounce it the K from your epiglottis. Okay, Richter scale. Okay, it measures the energy, while Marcelli measures the effects caused by SS. Measuring tool, this one does not have one, it's just observation. But you have the classifications of those observations also. But here you have the seismograph. Seismogram, I would rather say. What you plot on a seismogram is going to be called as seismograph. Calculation, it's quantified an observation of effect of the Earth's surface, human objects, and man-made structures. Okay, smaller of them, medium size, large size, how many of them fall, how many of them did not fall, and so on and so forth. Richter scale, it's on the base of 10, logarithmic scale, and amplitude of the waves as such. Scale, it's 1 to 12. 12 is total destruction. Nothing remains on the surface. While here it is 2 to 10. 10 we know is hardly recorded. And as I said, that an earthquake of 3 is 10 times more than as compared to the one at 2. So that's what log scale is. Consistency, it varies depending on the distance from the epicenter. This one varies at different distances. Okay, then I did speak about the Richter scale being on a log scale. You'll see that 1 is 10 raised to minus 1, 0, and then you have this. Okay, then you have second unit is 2, it's basically raised to 2. Okay, so this is how the curvature would look like. Okay, till 3, 4 we have already said it, they are minor ones. 4 to 5 are small, 6 is moderate, and then you start having stronger ones. Okay, till 5 fatalities are rare, but then beyond that it starts happening. Okay, 8 is major one, and then you have the great ones. I did say yes, Alaska 1964, New Madrid is in 1812, and San Francisco 1906. The largest recorded is in 1960 offshore of Chile. It's 8.9. I remember reading about this one that the earthquake was so impactful that it is believed, I don't know how much is true. I've never got the scientific clarifications about that, but it is believed that this earthquake actually reduced the axis of the earth and thus the rotational speed of the earth by some microseconds. So that could be an impact of an earthquake, and this of course eventually could be larger also. uh, just a few more things to be understood here. Logarithmic base of maximum amplitude measured in microns. You'll see here, it's here. Okay, these asterisks here, single asterisk effects may vary greatly due to construction practice. You'll see that in a developed country, this may not have much impact, but in an underdeveloped country where you have mud walls and a very basic level of habitation, okay, there these could collapse as such. Okay, a micron, by the way, is a millionth of a meter. Millimicron, okay, millionth of a meter. Okay, and this one here is three stars here. It's basically reads equivalent to a moment magnitude of 9.5. Okay, so that's another thing. And then let's look at this also. A Richter scale and earthquake energy. What do we mean by this actually? Each energy level is 10 times stronger than the previous one. Okay, so description wise, small, 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 small. 5 is moderate, 6 is moderate, 7 is major. Then you have the greater ones, and then you have the super earthquake as such. Occurrences till 4 you have daily, 5 and 6 is monthly. 7 is also monthly, but not that intense, I would say. 8 and 9 are yearly. While as far as 10 is concerned, we have said that it has not occurred, so that's why they have written rarely there as such. In population, every minute, every hour, every day, every week, every 10 years, every 30 years, every 50 years, every 100 years, every 300 years, and probably in 1000, one in 1000 years. We don't have a record of it. Movement is small till 3, moderate, sudden is 4, 5 and 6 is sudden storm, 7 is severe sudden, then 8 is very severe, 9th is of course going to be much, much severe. Okay, and the 10 is extreme. You will have difficult times if at every point of time you would have this particular type of earthquake. So this is a comparative chart, the scale at which we tend to use, which we tend to use as far as this country is called as a Richter scale. The other one is the Mercalli scale. Richter is more scientific, it is more methodological. Mercalli is also methodological, but then it is subjective because you are observing and then you are saying that, okay, the earthquake's destructive power is so and so. So it would be dependent. Okay? Meaning that what could be one value on a Mercalli scale in a developed country would be different as far as the developing, and it could be further different as far as the underdeveloped countries concerned. So that is something that we have to keep in mind as far as the Marshall scale is concerned. The Richter is very, very methodological and mathematical. Then, what are the various types of waves that would be generated? Normally, you'll see that seismograph is showing it this way. As a consequence, we would not know. And because it is unilateral, the needle and the pointer, we would not know how actually things move as far as earthquake waves are concerned. But I found these on the net, and let us understand them one by one. Okay, the first one is of course undisturbed material. You have the squares which are so very equal. Okay, the second one is how a primary wave, and after knowing this, we'll go back to what a shadow zone is. Okay, a primary wave is basically say the direction of movement. What happens is it compresses and it expands, compresses and expands, compresses and expands. This is what happens with the material as far as when the earthquake waves, the primary waves are moving. Okay, it's very similar to a fact that you must have been in a bus that has those things to catch, right? You are standing in the bus and the bus is crowded, and you'll see that you have people who are standing in the alley. Okay, people are sitting either ways, and then you have people who are standing in the alley as such. And the driver is, let us say, he's very rash. He keeps on braking every time, and then you'll see that because of that, what would happen within those people? Okay, when he brakes, they'll come together, and then they'll go back, and then they'll come together. Every time he brakes, people will move like this, front and forth, and this is what happens with particles or particles making up a solid material. Okay, this solid material, you'll see that they will move like this in the direction of proportion. It's very similar to a spring action. Take a spring and then you release it, you'll see that the spring keeps on doing this. So that is what is a primary wave looks like. Okay, as far as the secondary wave is concerned, okay, you'll see that it's literally up and down, up and down. Okay, this is near away, near away, near away. This is up and down, up and down. This is the secondary wave. Okay, these two are compared with light waves and sound waves also. Okay, one of them is light wave and one of them is sound wave. You have to tell me which of these, whether the primary wave is a light wave or sound wave, or whether the secondary wave is a light wave or strong wave, sound wave as such. Okay, so uh, secondary waves. Okay, now both of them are called as body waves, because they pass through the surface of the earth from one point end to the other end. They will travel. And that is why they are called as body waves. The third and the fourth waves, these are called as surface waves, because they don't travel deep into the surface, interior of the earth as such. They will travel only on the surface, and that is why they are called as surface waves. There are two types of surface waves. Okay, you have the Rayleigh waves and you have the love waves. Love waves is nothing to do with teen students. Let me tell you, students in your teen ages. The love wave here basically means the scientist by the surname Love and discovered these waves, and that is why these are called as love waves. Otherwise, students will start craving for having these love waves around them, so that it could create something very interesting around them as such. No, love waves are called so basically because, or after the scientist, just like Rayleigh waves, you have love waves. Love was the surname of that particular individual. Now, coming to the Rayleigh waves, how do the particles move? Remember, secondary waves, it was like this, up and down, up and down. You have to imagine this in a bit in 3 dimension. Now, this Rayleigh wave is circular. Things move like just like a wave you have in the ocean, right? A wave in the ocean coming out. Okay, you'll see that the water particles are moving circular, and that is why Rayleigh waves are amongst the most destructive. They just churn up the surface, and that is why they're very dangerous. Rayleigh waves. As far as love waves are concerned, the particles move this way. They are also equally destructive, but not as destructive as the Rayleigh waves. Going back to the bus as such, as far as the one we were seeing, is that if I'm going to use the same bus for all of us. Okay, a primary waves is basically the driver is braking, and then of course, so the people standing are moving together, away. Then, as far as the secondary wave is concerned, the bus is moving from on speed breakers, and because of that, you'll see that the bus goes like this, and the people inside the bus will move like this, daram, daram, daram. They'll shout at the driver as such. Okay. I'll speak about the love waves first with regards to the bus, and then we'll come back to the rally waves because they are very destructive. If the bus driver is driving like this, this way, okay, so the people will go this way and this way and this way and this way, and that is how you will the material which is making up the surface will also be moving this way and that way when the long wave is transiting between them. As far as rally waves is concerned, is that rally waves, there's something very unfortunate happens with the bus, and the bus goes tumbling down the downhill. Okay, if it's going to go tumbling down this way on the downhill, okay, then you would be calling them as the rally waves. So this is a hypothetical way of explaining how these four types of waves are. Remember, there are four types of earthquake waves, and another picturization of how they move is this way. Okay, P waves, you'll see that this is the undisturbed medium. This side, this side, this side, this. Okay, you'll see that you're going to have areas which are stretched and within the P waves, and you're going to have areas which are compressed within them also as such. As far as S waves are concerned, it's up and down and up and down and up and down. And as far as long waves are concerned, you'll see that, low waves are concerned, it's like this, okay, moving sideways. And rally waves, it's literally going round and round. And you'll see that the worst that the geometry tends to be broken as far as these four diagrams are concerned is the rally waves. So it's no wonder that the rally waves are going to be amongst the most destructive as such. Now, if we are to see this happening in the field, how should this look? Okay, this is how it should look for us. You'll see that this is normal when the earthquake has not happened. Okay, but then you have these P waves. Okay, you'll see that you have some areas wherein the fencing is going to break up, and some areas wherein it will close up. Okay, so that is how it is going to be. As far as the S waves are concerned, this is how it's going to be looking for, and the surface waves, they will cause a lot of destruction. Another way of looking at it, another way of looking at it is this diagram here. Okay, let us take up this first one here. In the back and forth motion, you'll see that all the communication networks are off. You'll see the road has crumpled and broken off as such. On the other hand, you'll see that S waves, okay, these things, it's like a bumpy ride for S waves, and you can see that being reflected in how the communication networks are there. It could be telephone line, it could be electric lines as such, electric poles, but this is just a representation of how it should be. Okay, as far as love waves are concerned, this is how it would look. Okay, it's happening sideways, let me tell you. Okay, and rally waves, you'll see that's total disruption. Okay, which you can see has happened here. So that is it. We have to go back to what is a shadow zone and how does it occur. I believe we don't have that much amount of time left with us. So what I'll do is I'll stop here. Tomorrow when we meet at the same time, we will revise this once again, the type of waves, and then we'll go to what is the shadow zone and how all that happens along with that. So that is about the waves and the instruments which are used. Let me see. There's only one comment, by the way. Bahar says that he has read that the 1964 Alaska earthquake was of a magnitude 9.2. Yes, it was a very, very severe earthquake. Fortunately, Alaska then was not much inhabited, I would rather say. and that is what. And in fact, people here did not know how much the impact that particular earthquake had had. It was only that after it happened that seismologists, people who study earthquakes, visited that particular place, and looking at the lithospheric structures, the breakages that had happened, gone through, they could say that yes, this was very drastic and very intense. Okay, and possibly they measured it at 9.2 as such. Okay, let me also tell you that when earthquakes happen, it's not only that on land surfaces, they happen through the crust, so they will happen in the oceanic crust also. And when they happen through the oceanic crust, it is seen that they create what we popularly known as tsunamis. Okay, Um as far as tsunamis are concerned, we know that when you have earthquakes at ocean beds, you have those very high magnitude waves that rise. Okay, it's basically the PS and the love waves or the ground waves which transfer their energy into the medium which readily accepts it. What happens with solids is they break off. If they are not elastic, they will break up. But water is significantly elastic, I would rather say, and because of that, it absorbs all that energy, and then you are going to have these waves, and these waves start traveling away from the epicenter, and you'll see that it's a very interesting thing to study, but of course it's a very dangerous thing to observe. It is said that this earthquake which happened in 2002, if I'm not wrong, which lashed the coast of India. Also, tsunami. Sorry, the epicenter was somewhere in Indonesia, and there is this story about a beach. I think it's Thailand or Philippines. I'm not very sure. Now you'll see that for the water to climb that particular height, it will need water, right? So when it comes near the coast, okay, and it has to climb up, what happens is it draws the water towards it, and it's a very gradual process. Gradual in the sense it happens fast, but it's not a very quick thing like somebody throwing water at you. So people on the beach suddenly started seeing that the water is receding, and many of them got curious as to Ami, I'll come to your question. I'll just finish with this. Many people who were playing on that particular beach were very curious as to why is the water receding, and they started walking towards that particular water, little realizing that just minutes later, a huge wave was going to lash. I think it was some coast of Thailand, in Thailand. It was not Bangkok, but some nearby place as such. People were enjoying themselves. They saw the water retreating. They thought something very peculiar is happening. They started walking towards that, and within minutes, you'll see that this huge wave, tsunami, just lashed onto the coast. And of course, one just can imagine the amount of loss of life and property that must have happened. You have these clips of various tsunamis, particularly those filmed in Japan, on YouTube. Okay, you can just type effects of tsunamis in YouTube, and you can watch these clips, and you can just imagine uh, so to say, the impact that these cause as such. Okay, there is one question which Ami says, "Sir, how deep does the focus of an earthquake lie?" I've already said that it would depend. You'll see that earthquake is basically an adjustment. Let me tell you that in geographical terminology, these are called earthquakes as well as volcanoes are called as constructive forces. These are called as constructive forces, though they would destroy life and property. Naturally, they are constructive because they are constructing the crust of this planet. So they're called as constructive forces. Okay. On the other hand, agents of erosion are called as destructive forces. Let me tell you. And they're called as construction basically because they tend to keep on adjusting this so-called lithospheric plates. Okay? And you'll see that when two large objects are going to bang into each other, they're going to set vibrations. It's very similar to that when two plates are going to bang, they're going to go past each other, they're going to ride over each other. One is going to go down, or they're going to move away from each other. The basis of plate tectonics is what I'm saying. Each of this is going to be where there is going to be some energy transaction that is going to take place. And this energy transaction could be very shallow rooted, or it could be deep rooted as such. So the focus could be from anywhere between 5 to 10 kilometers all the way to 800 kilometers. As I said, that the deepest of the recorded earthquake is somewhere around 800 kilometers. So possibly not beyond 800 kilometers is where the focus would be. As far as shallowness is concerned, it could be a few kilometers from the surface also as such. That is what my answer would be as far as this particular question is concerned. If you don't have any other questions, I would stop here for the day. And tomorrow we'll come back to knowing a few more things about the earthquakes. Particularly, we need to work out on the geometry of the shadow zone, how it happens, and how do those waves behave as far as the shadow zone is concerned. So if you don't have any question for now, I would be stopping in a couple of seconds from now. So that's all. Tomorrow, same time, we'll come back and let us see how much we can finish further. I'm stopping here for the day. Thank you very much. Have a great day.